So what we're going to introduce today is solving quadratic equations with what we're going to call imaginary numbers. Now, you guys have already gone through and watched the video on imaginary numbers on the YouTube channel, but before we kind of get into how we're going to go about solving these, I want you to try these two problems that are on your guided notes. So pause the video, go through and give both of these problems a try. So here are our answers to both of these questions. If you look at number one, it's very similar to our previous video and everything that we've been doing in class, but we're isolating x squared, we subtract 1, we divide by 2 by using our inverse operations, and we use another inverse operation here to cancel out the squared. Remember, that's not dividing by 2 because that is an exponent, it's not multiplication, so we need to go through and use square roots to actually get the inverse operation. And we get plus or minus 6 because there's two answers to this. Now, if we take a look at this, the problem here is, if you think about the definition of a square root, which is what times itself gives me the number underneath, there's no number times itself that gives you a negative. If you have positive 8 and positive 8, that's going to give you positive 64. And your only other option is negative 8 and negative 8 if the number is going to be exactly the same, which also gives you positive 64. So we have an issue. Just like in the previous video that you watched, there's an answer for this though. And there's a reason why we went through and we created this number I. 4 questions like this. Alright, so what it means to be imaginary, and again, this was all reviewed in that previous video. We have real numbers, doing air quotes with this, because those are the numbers that you guys are used to using, 3, 7, even things like 0.7 or fractions, all of which were outlined in the previous video. Or irrational numbers, a number like pi, which is 3.14, yada 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 yada, or square root of 3, square root of 2, all those different numbers. We've looked at the difference between rational and irrational numbers. We know what integers are. We know what whole numbers are. These are all subsets of real numbers because they don't have that imaginary unit right now. It's really there. It's like 0i, but they don't have that square root of -1, which you've been shown in that previous video. So there's a whole subset of real numbers, and then we have this little area over here for our imaginary numbers. What those numbers have, just like you'd seen in the last video, this is going to be key, understanding that I is defined as the square root of -1. It's defined as this. I is the square root of -1. And what that means is that I squared is going to be equal to -1, because if I look at this, if I'm going to square both sides, what I know is, well, the squared and the square root are inverse operations. Those are going to undo one another. So that just leaves me with I squared equaling -1. So understanding these two is going to be key, that I is equal to the square root of -1, because that's going to help us solve questions just like that second question in the do now, which is right here. So we're solving this. Again, that means we're looking for its x coordinates. We're going to plug in 0, x squared plus 64. And the solving process is identical to everything that we've gone through and done recently. Just now, when I get to this point, what I'm going to do, those two are going to cancel one another out. And just like in the previous video, we're going to split this up. We're going to split up the square root of -64. We're going to split it up as the square root of positive 64 times the square root of -1. We can go ahead and we can do this because of those exponent properties for everything that we've really been doing for the last few classes, is just splitting these up. So now I'm going to solve this as I'm going to look at these as two separate pieces. I will break down the square root of 64, and I will break down the square root of -1. Square root of of positive 64, I should say. When I look at that, I know how to break that down. That's plus or minus 8. 8 times 8 gives me positive 64. -8 times -8 gives me positive 64. This value here, the square root of -1, is defined as I, that imaginary number. So instead of writing the square root of -1, because that comes up so often, mathematicians are a little bit lazy and we want to just give ourselves a shortcut here. Instead of continuing to write this, we're going to write I, because that's a lot easier than writing that every single time, especially in a long problem. But this would be our final answer, plus or minus 8i. And really, it's not much different than everything that we were doing. It's just including this imaginary term. So, looking at these two examples, what I want to do now is the same exact thing. We're solving them. So we're setting them equal to 0. We're finding our x-intercepts. So I'm going to go ahead and do this one. And honestly, you guys go ahead and do this one on your own. So try it, pause the video, and then check to make sure your work's good. So if we take a look at this problem, very similar to everything that we've been doing. Work from the outside in, isolate x, use inverse operations here, subtract 48 on both sides, divide by 3. That gets us to x squared equals negative 16. We're able to take the square root of each side, and from there we break this up into 16 and negative 1. And we're taking the square root of each of those. So we break down each part. This is our real number, so we just continue to do that as we've been doing for the last few days. Break that down, and then the square root of negative 1 would just become I. Now, I wanted you to just do number 1. Number 2 will be a little bit different because we'll have to do a little bit more. But not anything that you guys can't handle. It's very similar to everything that we've been doing. We would subtract 10 on each side, which gives us 3x squared equals negative 36. This part we should be able to do in our sleep. We've been solving these kinds of equations all year long, the beginning part, just the subtraction and the division. We should be good with that. Now, at this point, this is where things are going to be a little bit different. Just like we've been doing, take the square root of each side. That's going to cancel out our square term over here. Now, if I look at this, okay, I'm going to break this up into 12 and the square root of negative 1. Now, square root of 12 doesn't break down so nicely like we had over here where we had 16 and in the previous example where we had 64. So I have to go through and break this down like I had any other square root. I have to either use prime factorization or my number sense method. I'm going to go ahead and use the number sense method. Say that breaks down the square root of 4 and the square root of 3, all still multiplied by the square root of negative 1. That square root of 4 becomes 2 plus or minus 2 times the square root of 3, and we can change this to become I. Now, looking at this, just a way of formatting this, the way that it's typically done is it'll be all written x equals, we'll do our plus or minus the real number, the I will go in front of the square root sign. That's just kind of a formatting thing that usually happens. Are these both the same exact thing? Yes. This is just typically the way it's written. The I typically goes in front of the radical sign. But that would be our answer. Again, it's the same stuff. It's just now we ended up breaking down that square root of 12 a little bit more. What that looks like on a graph. So this is the first example. Y equals x squared plus 64. If I notice, if I plugged in and I was solving for my x-intercept like we had in the previous example, it gave us the two numbers on this x-axis where they intercepted. Now, if I'm looking at this, I have two imaginary numbers. So what that's going to end up meaning in my quadratic is I'm not going to intercept at these 2 points, because what that means is those are our two real solutions. If I'm looking at this, there's going to end up being two imaginary solutions, and that's something we'll discuss in class about the whole imaginary axis and just what that really means. That's something that we'll go over more as a group when we're all together. But just keep that in mind. If I have imaginary solutions, I am not going to intercept the x-axis. I will have both of my answers on the imaginary axis.